Okay, so far we looked at quadratic equation, how to solve them, what the nature of the solution looks like depending on the value of the discriminant, and then we learned how to create a quadratic equation if you are given the answers. Okay, before graphing, I want you to recall that a linear equation, meaning the power of x is 0 or 1, it looks like a straight line. And if I take a general equation y equals mx plus c, it gives us all possible lines by varying the values of m, which is the slope, and c, which is the y-intercept. And this is what varying these values do. Where you vary m, it's a line, the line rotates. So the physical action corresponding to varying the slope is rotation. And the physical action corresponding to varying c is vertical movement or translation. And in general, by rotating and moving things, you can achieve all possible states or all possible positions in 2-dimension. So what does a general quadratic y equals ax squared plus bx plus c look like? The shape is called a parabola. Let's see what it should look like. For a brief intuition, let's start with the function x squared and make a table. Now when x is 0, y is 0. When x is negative 1, that's 1. That's 4, 9. 1, 4, 9. So one immediate thing we see is symmetry. The negative values give the same output as the positive values. And if I plot these points, 0, 0, 1, 1, 2, 4, 3, 9. Negative 1, 1, negative 2, 4, and negative 3, 9. And I combine them, this is not perfect, but these are curved, right? It's not straight, it's curved. And the shape is called a parabola. So in general, we know what it looks like, what the shape looks like. Now the x squared terms creates a sort of symmetry for the negative and positive values of x. And this is what creates this parabolic shape. Now there are some terminologies, just like for a line, you had slope and intercept, we have some special terms that we need to know about. Given any parabola, the lowest point, or it could be the highest point, is called the vertex. And then if you take a line through this vertex, which is parallel to the y-axis, that's the axis of symmetry, because everything is on the left and right of this is the same. And then you have the regular x-intercept and the y-intercept, meaning where they cross the x-axis and where they cross the y-axis. So the vertex is the lowest or the highest point. Axis of symmetry is the vertical line through the vertex around which the graph is symmetric. X and y-intercepts are where they cross. For a general parabola, when you have ax squared plus bx plus c, if this first coefficient is positive, it's an upward opening parabola. If a is negative, it's a downward opening parabola. And you can check that. Example, if I have x squared, we saw the shape is that. And if you repeat that process with negative x squared, the shape is going to be something like that. Now again, to tie everything up, we're going to use the completion of square in order to graph them. Now any quadratic can be rewritten using completion of square as a times x minus h squared plus k, where h and k can be seen from the derivation of the quadratic formula. This h is going to equal negative b over 2a, and k is going to equal c minus b squared over 4a. Let me take you back to the derivation so you can see those terms right here. Something squared equals something else. Right? So that's the idea here. Coming back, then these values of h and k, that's where the vertex is. For example, let's graph this equation. First of all, let's start with easy terms, or let's say the y-intercept. The y-intercept is when x is 0. When x is 0, y, which is f of x equals 0 plus 3 squared plus 1 gives me 10. So the y-intercept is at 0, comma 10. X-intercept, that's when y, which is f of x, is 0. So in this case, x plus 3 squared plus 1 is 0. And this will give me no solution in real numbers. We will see in a moment what that means. This means there is no x-intercept. Now let's find h. That's negative b over 2a. Let's expand this so that we have the standard form, which is ax squared plus bx plus c. That's x squared plus 6x plus 10. So b is positive 6. 2 times a is 1. This gives me negative 3. And k, which is c minus b squared over 4a, is 10 minus 6 squared over 4, which is 10 minus 9, which is 1. So the vertex is at negative 3, comma 1. Now let's draw this. So I know it's a parabolic shape, and the lowest point is at negative 3, comma 1. Sorry, I had some issues writing there. So the lowest point is at negative 3, comma 1. That's right there. And it's a parabola, so that's the shape. And we determine the y-intercept to be 0, 10. And it's clear from here that there is no x-intercept, which makes sense because there is no real solution. So there is no x-intercept. Okay. In general, what this means, remember discriminant, right? If discriminant is greater than 0, then your parabola is going to look like this or like that, because you have two values of x, right? Remember, because there's two solutions to x. If your discriminant is 0, then there is exactly one solution, so it's going to look like this or this. There's one solution for x. But if the discriminant is negative, then it's either completely on the first two quadrants or completely in the second two quadrants, because there's like no real solution. Another example. Again, y-intercept is negative 2 squared plus 1, which is 5, so that is 0, comma 5. X-intercept is when x minus 2 squared plus 1 is 0. Again, there is no real solution. File this out. Negative 4x plus 4 plus 1, x squared minus 4x plus 5. So there, a is positive, so it's upward facing for sure. All remains to be done is find the vertex. Negative 4 over 2, 1, 4 over 2, which is 2. K, which is c minus b squared over 4a, is 5 minus 16 over 4, which is 5 minus 4, which is 1. And again, that makes sense. If this is the vertex, that's what the parabola looks like, and that point is 0, comma 5. The vertex is 2, comma 1. And if you have the vertex, you also know where the axis of symmetry is. The axis of symmetry is x equals 2. And there's also a direct way to find the vertex of the parabola. The vertex is at negative b over 2a and f of negative b over 2a. Now this is why this is true is really simple. This is f of x. If you know that the x coordinate is going to be negative b over 2a, and it's going to be on the function, so you can plug that in there to get the y coordinate. Okay. So for example here, find the vertex. You can directly find the vertex as the x coordinate or first let's find negative b over 2a. That's negative 12 over 3, which is negative 4. And then f of negative 4 equals 3, 16 minus 48 plus 8. That's 48, right? 48 minus 48 plus 8 is 8. So the vertex is at negative 4, 8. What about A? A is positive, so it's an upward. So immediately, even without solving, you know that there are two real solutions to this problem. That's it for